All right, welcome to Unit 3, Day 2. Today we're going to learn about ions and their formation, and we're going to differentiate between anions and cations, and we're going to predict oxidation numbers. All right, so for ions, so far we've only been learning about neutral atoms, okay, where the number of protons is equal to the number of electrons, but this is not always the case, okay? When you have an unequal number of positives and negatives, you will end up with an atom that has an overall charge. This charge can be -1, +2, 0, and so on, okay? Any atom with a charge is called an ion, all right? Often atoms will lose or gain electrons, and this helps them to become more stable. When an atom loses its electrons or gives it away, it becomes positively charged. Positively charged. Think of it as giving away your debt, which is in the negative. You will have more money than what you started with. When an atom gains an electrons or gets a negative charge, it becomes negatively charged, okay? So your metals will form cations. Remember, your metals are on the left-hand side of your periodic table and in your transition metals, okay? So your metals will almost always lose their outer electrons, forming positive cations, okay? Think of cations. If I were to write the word out, C-A-T-I-O-N-S. This T, think of it as a giant plus sign. Okay, so sodium lost its electron and became sodium +1 or +1 electron. Calcium lost its 2 electrons, so it became calcium +2. Aluminum will lose its 3 electrons, so it will become aluminum, Al +3. Okay? Each time the metals lose their outermost valence electrons, the energy level below is full, okay? Your nonmetals will form anions, so they almost always gain electrons and become negative anions. Chlorine is in group 17, so it will gain 1 electron and become chlorine -1. Oxygen is in group 16, so it'll gain 2 electrons and become O -2. Nitrogen is in group 15, so it will gain 3 electrons and become nitrogen -3. Your nonmetals will gain the number of electrons needed to obtain 8 valence electrons, or a full octet. So remember, your noble gases is in group 18, so it has 8 valence electrons. Your halogens right here are in group 17, and they have 7 valence electrons. Group 16 has 6, 15 has 5, and so on, okay? So think of your noble gases, again, their nobility or royalty. Everybody wants to be like them, okay? Everybody wants to have 8 valence electrons. So they're going to do anything they can. They're either going to lose electrons or they're going to gain electrons to become a full valence shell. Okay, so we like to say that they're snobby royals. They don't like to bond with peasants, so they don't need to bond because they have a full octet. They are nobility or royalty, and all the other elements in their period want to be just like them. Okay, so remember your octet rule. Atoms will either gain, lose, or share valence electrons in order to obtain a full set of 8 valence electrons. So there are 3 types of chemical bonds. We have ionic, covalent, and metallic. All right, the first one we're gonna study this year is the ionic bond. It's a fun one. All right, an ionic bond is an electrostatic attraction between a positive atom, also known as a cation, and a negative atom, also known as an anion. Okay. Ionic bonds involve the transfer of electrons from a metal to a nonmetal. And they do this so that they each may obey the octet rule, okay? So you have sodium here. Sodium has 1 valence electron that it wants to get rid of. And chlorine over here has one valence electron that it wants to gain. So together, it shares that one electron and becomes sodium chloride, which is also known as table salt, the most famous salt of all. Any ionic compound is a salt. The outer electron of the sodium transfers to the chlorine, then the oppositely charged particles attract. So remember, think of your magnet. You have on one side a negative, on one side you have a positive, and then if you try to stick a positive with it, positive with a positive, it doesn't work. But if you stick a positive with a negative, it bonds famously. Okay? Your oxidation number is the charge an atom would have if it became an ion. So whenever an atom gains or loses electrons. Okay? The A group elements tend to follow this set of pattern, and you will need to know these. Your transition metals or your B group metals can have multiple oxidation states. You only need to know the exception block. Okay? So pull out your periodic table if you have one, and we're going to color in this good little area where you have aluminum, gallium, indium, zinc, cadmium, and gold. And then you need to come over here to your alkali metals and put a +1. We're going to color it one color, okay? Then you're going to go to your alkali earth metals, color it its own color, plus a +2, okay? So your exception block were those first ones that we colored in. You're going to put a +1, zinc and cadmium, you'll put a +2, and aluminum, gallium, and indium, you're going to put a +3, okay? Then over here, we're going to put on group 14, you'll put a -4, group 15, a -3, group 16, -2, and so on. Then you need to have them colored with their corresponding color, okay? Then your transition metals are these nice ones in the center, except for your exception block, and your lanthanide and actinide series down here. All right? Up next, we're going to characterize these elements. So group 1, we have sodium. It has an oxidation number of +1, and it is a cation. Okay? Is it a metal or not a metal? We're going to say it's a metal. Magnesium is also a metal. Its oxidation number is +2, and it is a cation. Aluminum is a metal. Its oxidation number is +3, and it is also a cation. Then we're going to go to silicon. It is also a metal. It has an oxidation number of -4, and it is an anion. Phosphorus is a nonmetal, has an oxidation number of -3, and it is an anion. Sulfur is a nonmetal, has an oxidation number of -2, and it is an anion. Chlorine is a nonmetal, oxidation number of -1, and it is also an anion. Lastly, we have an argon. It's in group 18 with your noble gases, so it's going to be a nonmetal. It has no charge, and it is neither an anion or a cation. And that's it for today. Good job.